Welcome to this recording. This is Lydia, and I'm going to be talking to you about how to solve percentage problems using a method that I teach in my math classes. So you'll see that I have a diagram here, and it's kind of a silly diagram. It almost has a Halloween theme to it. And you'll see that I have 4 squares, and in some of those squares I have some animals. And this is kind of, for those of you who think visually, it's a way for you to remember the location of different objects. So in that top right corner where you see the bat, this is where I use a percentage, where we have the little rat, that's the part, and where we have the big fat cat, that is the whole. So now you can see that this diagram has been transformed from something that was silly with a lot of cartoons into something that is going to help you to set up and solve your percentage problems. So there are really just 3 steps when you use that diagram. The first step is to fill in the information you have based on the word problem. You then take the 2 numbers that you have that are situated from each other diagonally and you multiply them. And once you do that, there's only one remaining number left in your little chart, and you simply divide by that remaining number to give yourself the answer to the problem. I'm going to go through some examples with you now. What is 98% of 200? So here I have my diagram, and I fill in the info. 98% goes in the little box for percentages. And I go back to the problem and I read it again. What is 98% of 200? So I'm looking for a percentage of a whole, and that whole is 200. So I fill that in. And you can see now that I have 2 numbers that are situated from each other diagonally. So I'm going to multiply them. 200 times 98 is 19,600. I have only one number left in the diagram that I have not used, which is the 100. So I'm going to divide by the remaining number. 19,600 divided by 100 equals 196. So now I have the answer to the first problem, and I go back to the question to review it and make sure that I really did answer the question. The question is, what is 98% of 200? Well, 98% is almost like 100%, or the entire 200. And when I look at the answer of 196, 196 is very close to 200, so it makes sense. Now that you've had a chance to see how this diagram works, I want to talk to you a little bit more about the rationale behind the diagram and why I've used the images that I've used. Now when you look at the diagram, you see that it has 4 squares, and the 100 is always in that bottom right square. That's the one number that never changes its place, and you can always write it in. The percentage involved is going to be that bat, and like I said, it kind of looks like a percentage. And then the reason we have the little rat and the big cat is because the big cat represents the whole, and the whole is usually larger than the part. So that's why the cat is bigger than the rat. Usually a percentage is part of a whole. So if I did 40% of my homework, I didn't complete all of my homework. I just completed a part or a small rat-sized portion of the whole big cat-sized amount of homework that I have to do. Now, in some situations, it's not always logical to have the small rat and the big cat. So let's say, for example, that I do really well at work and I get a raise. And what I earn next year will actually be 110% of what I earned last year. When I put the numbers in, that's going to end up creating a part that is larger than the original whole, the original cat, because I'm going to be earning the same salary I earned plus 10% more. So this doesn't always work, but for the majority of problems that you'll be using in this class, it will absolutely work for you. Let's go on to another sample problem. In this sample problem, the question asks, what percentage is 43 of 56? And notice that the question is actually asking about the percentage. What percentage is 43 of 56? We don't actually know that percentage, and so we have nothing to fill into the percentage corner of the diagram. Instead, what we're given is a part and a whole. The part is going to be 43, and it's a good guess that it's the part because it is smaller than 56, but also if we look at the way the problem is worded, we know that it is a part of a whole. What percentage is 43 of 56? So that wording is a clue to us. 43 is a part of 56. 56 takes the place of the whole. And now we can multiply across, now that we have two numbers situated diagonally. 43 times 100 is 4,300. And we locate the remaining number we have not used yet, which is 56. And we divide 4,300 by 56, giving us 78.8% as an answer. Now I go back and I look to see if I answered the question. What percentage is 43 of 56? Well, according to our calculations, 43 represents 78.8% of 56. And if I think about it, this also makes sense. I wouldn't want 43 to be 80 or 90 or 95% of 56 because it is too far away. It isn't 50, it's not 49, it's 43. So it's about 3/4 or 75% of 56. So logically, to me at least, that makes sense. We have shown that 43 is 78.8% of 56. Now I have one final general example to talk to you about today before I begin to review the results of last week's math quiz online, which I think you'll find a bit more interesting than this generalized example. In this final example, I'm asking the question, 27 is 60% of what number? Again, 27 is 60% of what number? Now I see that I have 60% in the problem, so that's very easy to figure out where that goes. It goes up in that percentage corner. And I'm saying 27 is 60% of what number? Now where does that 27 belong? Is that the part or is it the whole? Well, I'm saying that 27 is 60%, or it represents 60% of another number. In other words, 27 is just a percentage of a larger number, a part of a whole. So 27 is going to go into the upper left-hand corner. It is just the part. What we're trying to find out is the whole. Now that I have three numbers in the diagram, I'm going to multiply the numbers that are situated diagonally. 27 times 100 is 2,700. And I'm going to use the final number that has not yet participated in any of the calculations. That's 60%. I'm going to divide 2,700 by 60 to give me 45. Now, by this time I've forgotten what question I was trying to answer, so let's go back and ask the question again. 27 is 60% of what number? Okay, so 27 is 60% of what number? Of 45. Now let's look at some of the difficulties that you may have encountered while taking last week's online math quiz. The following problem deals with percentages, and you had to find the whole when given information about a percentage and a part. And you'll see at the bottom of my diagram here, 10 people got this question correct, that's in blue, and 4, 5, 6, 7 people got it wrong, that's in yellow. The question asks the following. Just 2 students out of a daycare's total attendance come from divorced families. If this represents 5% of the total number of students, how many students does a daycare serve? So now I'm going to begin to fill in the info, and I'm going to identify the info. What are the digits I actually have here? I have the word 2 students. I'm going to put that somewhere on the diagram, and then I have 5%. Those are the only numbers I have. The 2 is part. 2 students out of a daycare's total attendance are from divorced families. So I don't really know how many students does a daycare serve. In fact, that's what the question is. I want to know the whole number of students that the daycare serves. I only know 2 of the students, so that's a part. The 5%, since it's a percentage, goes in the percentage corner of the diagram. And now I'm just going to multiply across. 2 times 100 is 200, and divide by the third number, which is 5. So 200 divided by 5 equals 40. Let's go back to the question. 2 students come from divorced families. That represents 5% of the total number of students. How many students does a daycare serve? The daycare serves a total of 40 students. So there are a lot of students, 40 students. Only 2 come from divorced families. And those 2 are only 5% of the total number. This makes sense. It's not 50%, it's not 60 or 70 or even 10%. It's only 5%, so I would expect that 2 students would be a very, very small part out of a much larger whole of 40. So this gives me my answer. There is a total of 40 students at the daycare. Only 2 of those students was 5%. I wanted to know the whole, which was 40. I'm going to talk to you about another problem that many students had difficulties with. In this problem, you had to look at the number of calories that a child was eating, and you were given a percentage and a total, and you had to find the part. So let me read the problem to you. For breakfast, a daycare menu provides each child with half of a hard-boiled egg. Half of a hard-boiled egg has 39 calories total, 28% of which counts as fat calories. How many of the total calories are fat calories? Rounded to the nearest number. And if you look below in blue, 12 of you got this right, but 2, 3, 4, 5, 6 of you got it wrong if I counted correctly, so that's why I'm reviewing it with you. Now let's take a look at the numbers that are given to us in the problem and see how we can fit them into our diagram. You have this word half of a hard-boiled egg. This is actually a distractor. We can get rid of that half. The number 39 comes up and it says 39 calories total, and then 28%. Well, the easiest of these figures to put in is going to be the 28% because we know that all percentages go into that upper right-hand corner. Now let's look at those 39 calories total. Is that going to be the part or the whole? Well, let's look at what the question is asking us. The question is asking how many of the total calories are fat calories. Presumably, the egg isn't entirely composed of fat calories. So in fact, the fat calories that the child is consuming when eating the egg is only part of the total calories. So that 39 is going to go in the position of the whole. Setting up the problem is really the hardest part, and once we have that done, we can just go ahead and do our calculations. We can multiply across. 39 times 28 is 1092, and divide by the remaining number, which is 100. 1092 divided by 100 equals 10.92. Let's go back to the question again. How many of the total calories are fat calories rounded to the nearest whole number? And I can see when I scan my multiple choice options, there is nothing there with a decimal point. So what am I going to do with this 10.92? I have to round to the nearest whole number. Well, if I look at 10.92, the 0 is the location of a whole number. So if I want to round the location of the 0 in 10, that means I'm going to look at the number directly to the right of the location to which I want to round to, and I see that that is occupied by the digit 9. Now, if the number located directly to the right of the number to which I want to round is equal to 5 or is greater than 5, this means I get to round up. And in this case, since the number I have is 9, that means that I get to round 10 up to 11, making our answer be 11. So let's go back to the problem again to make sure that this makes sense. The kids are eating half of a hard-boiled egg, which has a total of 39 calories. And 28% of those are fat calories. So 11 out of 39 is fat, and that 11 out of 39 is equal to 28%. That makes